Okay, so this is going to be a video on K4 last letter, so ELL. It can be applied to really anything. The one thing that it does require is a pretty decent knowledge of commutators. Get this lighting a little bit better. Yeah. Okay. You need to know how to do commutators in order to do this. But other than that, it's mostly intuitive. So looking here, looking around the cube, there's really nothing solved. So the first step in the methodology that Tom and I came up with was to solve one edge at a time, basically. And then, so it's 3 algorithms. So you do one edge, then another edge, and then the last 2 edges. So right off the bat here, this is the most advanced case you can get, where you kind of have to do 2 commutators at once. So here I see the red yellow and the red yellow are in a different plane than the red spot, or the spot they need to go in, but they're in the same axis. So as you can see, I can just do that to pair them up. So what I want to do is, if you can see, if we need to get these 2 pieces here, we can split them apart and then move this here and then put them into place, undo that, and then undo our setups. So I just use 2 commutators to kind of put together, where I guess the B of one commutator is the same as the A of the other. So what I do is I move this out of the way, so I drop it down, then that way I can bring its position in the spot. So that would be the one commutator to solve that. But because these 2 are in the same plane, I can solve both of them at the same time. So that's the trick to doing multiple commutators in the same time, is find a way that they can both be so both edges are in the same, or are in the same, I don't know if it's this same plane, but on different slices. That way you can just stick the edge in there, put them together, and then take the edge out. So that's one edge. Next edge is easy since I have this green one solved. I'm just going to solve a simple commutator. I could have done this one. And then, so that leaves me with 2 edges, and then here is just a simple commutator, and then undo the setup, and you're done. So let me do that. Well, let me do another scramble. Okay, so here's another scramble. This one is pretty simple, or straightforward. There's a couple things you can do. First, what I would do, I guess, is just, I see this red, again, we're going to solve one edge at a time. So we have one edge that's almost solved, so I'm just going to solve the red piece. Okay, and then that leaves me with this configuration, which is weird. But so the next time I want to solve it is, I could do one of 2 things. One, I could do a commutator like this. To solve the yellow, orange, or what I usually would have done, which isn't smart, I guess, was to solve the blue by just doing a 2 flip. But then right now I just have 2 edges, which is PLL parity, and I undo the setup. Let me do one more that's a little bit more challenging. Okay, so here's another scramble. Again, pretty easy for this one, but instead of that, I'm going to show you a more difficult case that sometimes you have to do. So I'll solve the orange edge. So if you can see, there's an orange piece here and an orange piece here. Now before, when I was telling you how to combine edges, what I said you had to do was have them in the same plane but in different slices. So the way to do that is to just do an F2. That way an R2 will pair those up so that they're able to be paired up. Now, in order to do that, in order to do the commutator right, we want to have to move this out of the way, put this into place. So what we do is an L2 setup to bring it down here. So that we pair these up, then move the orange spot over, and M2 to solve both of them at the same time, and then undo that and undo that. So that gave us the two edges. So again, we had orange and orange here and here, and they need to go here. So we can either do, it doesn't matter, we can do either F2 or B2 or F2. That way the orange pieces are in the same plane but different slices. And then just move it out of the way. Now what you can't do is you can't just do an L move, an L prime, because then you're using this piece as a commutator. So you have to do the L2 there, so that you're switching with a different ELL piece. So basically you're pairing these up, and then moving the orange spot over, solving it, undoing the setups, and that solves the orange edge. And now here, just simple commutator, 3x3 ELL. So that gives us the last two edges, which is just a 2-cycle. So I do the setup, do the parity, and I'm done, undo the setups, and I'm done. So that's kind of like the whole basic idea. So you can always solve in 3 algorithms. Everything's really intuitive except for the last 2 edges. There's some cases like double parity, that parity, that's the 2-cycle, 4 cycles, which I learned for 5x5 a while ago, where you can see it's a 4-cycle. But they're 2-gen, so, and they're pretty nice algorithms. I've known them for 4 years now or something like that for 5x5. And so other than a couple of algorithms that you need for the last 2 cases, everything else is intuitive, and you can always solve it in 3 algorithms or less. Sometimes you'll get lucky and the stuff will just come into place. So yeah, that's really it. I really don't know what else to talk about. So like, this is one of those commutators where you're solving, I'm only looking at solving one edge, but you actually solve all these pieces. But it's 2 commutators kind of put together, and they solve 2 pieces at once. So yeah, so I guess that's it for K4 ELL.